Okay, what we're going to work on today is we're going to work on the 7-3 notes to prepare you so you can go ahead and get to the 7-3 homework. Now, I will tell you that this lesson, as far as the next few lessons, require a lot of factoring, so make sure you have those skills in your back pocket ready to go. I'll try my best to walk through some of the basics of it. But I would suggest that if you have this pink cheat sheet that we've been using all school year for factoring, I would suggest having it. I think it will lend a good hand. Okay, so as we're looking through this section, okay, we are seeing two learning targets. The first, that you can simplify rational expressions, and secondly, that you can multiply and divide rational expressions. Okay, so as I think about a fraction, specifically, let's just use an example such as, like, let's just think about the fraction 6/8. Okay, I think for the most part we know it's 3/4, but let's explore a little bit about why it is 3/4. So I know that 6 is the same as 2 times 3, and that 8 is the same as 2 times 4. Well, now I have a fraction, and I have a factor of 2 on top and a factor of 2 on the bottom. So naturally what happens here is that these like cancel out to the number 1, right? These each cancel out to the number 1. 1 times 3 is 3. 1 times 4 is 4. And so that's why these two things are actually equal to each other. Okay, and so we're going to be doing a fair amount of that. Okay, and then we will also, as we go, talk about like how we multiply fractions and divide fractions as well. Okay, so first learning target is just simplifying them. Okay, simplifying is going to pop up all the time. You're going to need to know how to do these because it's going to be layered within other parts of problems that are longer, and it's not about simplifying the fractions, but you're going to need to be able to simplify the fractions to be able to get your final answer in a nice, neat form. Okay. So as I'm simplifying rational expressions, I need to look and see whether these expressions can be factored down the same way as 6 was factored into 2 times 3. It's just how we factor is going to look a little bit different. So as I'm simplifying, okay, I have x squared minus 4x minus 12. Okay, so I have a 3-term trinomial with my a value equaling 1. Okay, so if you need to refer back to this sheet and how we factor this, okay, we are always going to take a greatest common factor out, and then you ask how many terms it is. Okay, so I'm looking at 1, 2, 3 terms. Okay, so I have, how many terms do I have? I have 3 terms. Does my a value equal 1? So ax squared bx c. So a here is 1. So yes, my a value is 1. So we're just looking for values that multiply to the c value, negative 12, and add to the b value, negative 4. So what I want you all to do right now is take a moment and think about what numbers multiply to negative 12 and add to negative 4. Okay, so hopefully you came to the realization that that is negative 6 and positive 2. So x squared minus 4x minus 12 factors into x minus 6 times x plus 2. Okay, so now I got to ask if this part can be factored. Okay, x squared minus 4. Okay, so let's go to our factor sheet. How many terms are there? There's 2 terms. And so I got to look for special patterns. Okay, so difference of squares, difference of cubes, sum of cubes. Difference, subtraction, squares, perfect squares. So is x squared a perfect square? Is x squared a perfect square? It is. Its root is x. 4 is also a perfect square. Its root is 2. So this is going to factor into x plus 2 times x minus 2. So just in the 3/4, 6/8 example, we have common factors. We have common factors in x plus 2. So these parts can cancel each other out. Okay. And so then all that we are left with is x minus 6 over x minus 2. And that's just my final answer. Okay, now one added layer here that I want to put in so you don't have to worry about this later is excluded values. We've talked about excluded values. Okay, excluded values are values that are going to make me divide by 0, and that's at any point in the problem. So here's a good way. We know that x plus 2 can't equal 0. So when I subtract 2, we know that x cannot be equal to negative 2. And then we also know x minus 2 can't be equal to 0. So that means when I add 2, x cannot be equal to positive 2. So my x values can't be negative 2 or positive 2. This is not part of our work today. I'm not going to require this from you today, but it will pay dividends later on. Okay, so again, lots of factoring that you're going to need to know how to do. Okay, so if you're still struggling with factoring, there's great resources on, if you just Google how to factor, there's going to be all sorts of resources, or you can go back through our work itself, starting in Chapter 4, as well as Big Time Chapter 5. Okay, let's do number 2. So number 2 is x plus 4 over x squared minus 16. So I'm looking at x plus 4. There's 2 terms. Okay, but x is not a perfect square, so that means x plus 4 is just simplified. Okay, second one, x squared minus 16. It's got 2 terms, so I'm looking for a difference of squares, difference of cubes, sum of cubes. I'm looking at the difference ones only because it's subtraction. X squared is a perfect squared, 16 is a perfect squared, so we know that this is a difference of squares. So what's the root of x squared is x. What's the root of 16? It's 4. Okay, we have a common factor here, in here. And remember, they cancel out to 1s technically. So on the top, I just have 1. And on the bottom, I have 1 times x minus 4. Okay, if I wanted my excluded values here, okay, I would say that what's going to make this 0? Well, that's negative 4. So x cannot be equal to negative 4. And then if I look here, what would make this 0? It would be positive 4. So I can actually just condense that down and say x can't be equal to plus or minus 4. Okay, so now's a great time. Pause your video. Go ahead and try A and B on your own. Okay, so I'm assuming that we've already tried A and B independently, and we're looking to check our work. Okay, so I'm looking at the top one, A. 2x plus 2 can actually be factored because the first step is always to find a greatest common factor. Okay, so this means it's 2 times x plus 1. Okay, here, 3 terms. A value is 1. 3 terms. A value is 1. We're looking for numbers that multiply to 3 and add to 4. Okay, think about what numbers multiply to 3 and add to 4. Well, that's going to be 1. So we're going to have x plus 1 and then also 3. Okay, common factor of x plus 1. Those cancel out. And I'm left with 2 over x plus 3. All right, let's find our excluded values. This can't be equal to 0, so that means x can't be negative 1. This also can't be 0, so x can't be negative 3. But again, right now I'm most concerned about this because that's our learning target. This is just going to help us a little bit down the road. Okay, B. Top one, I have 3 terms and my A value is 1, so I'm looking for numbers that multiply to negative 3 and add to negative 2. Okay, so multiply to negative 3 and add to negative 2. That's going to be negative 3 and positive 1. Okay, next one is going to be add to negative 6 or multiply to negative 6 and add to negative 1. That's x minus 3 and x plus 2. I do have common factors here in negative 3. So that means my excluded values are going to be, well, x can't be 3 because that would make me this 0. And then x can't be negative 2 either. Okay, and then my final answers are going to be x plus 1 over plus 2. Okay, so if you're really struggling with this section, I would actually suggest now pausing your video and reaching out to a teacher and getting some assistance, because this is going to be very, very layered throughout the rest of our work that we're doing. And I'm realistically going to probably move through it relatively quick. Okay, so if you still need help with this first page, seek one of us out and get some help. Okay. So now what we're going to do is we are going to move on to multiplying rational expressions. Okay, so there's a couple different ways you can do all of these different ones here. But for me, what I like to do is just kind of organize my work. I like having all my x's next to my x's and my y's next to my y's if I could possibly make that happen. And in this situation, we can make it easily happen. So let's think about two really important facts. The first is, how do you multiply fractions? So if I'm trying to multiply fractions, if I'm trying to multiply a half times 3/4, half times 3/4, you multiply straight across. This is 3 and this is 8. Okay, so you can multiply straight across. Pretty straightforward. Okay, so when I'm looking at that, let's just kind of multiply straight across. And we should know by now that multiplying straight across and multiplying in general, you can do that in whatever order you want. So let's do the 8 and the 7 together. So I'm just going to, so 8 times 7, we'll put that together. Then x to the third and x to the fourth. So all I'm doing is just reorganizing this for me, so it's in a way that's just easier for me to work with. Okay, so I'm putting this all together, and then now I'm going to do the bottom. Okay, so I'm going to have 2 and 4, so I'll go 2 times 4. And then I'm going to go x times, well, there's no other x, so it's x by itself, and y squared and y cubed, or y squared and y. Okay, so now we need to know our exponent rules. For example, when I am multiplying together, I add the exponents, okay? So 8 times 7 is 56, okay? X to the third times x to the fourth, that is x to the seventh. And y times y to the third is y to the fourth, right? All I did here is 3 and 4 together added is 7. 1 sneaky 1 here, and 3 is 4. Okay, let's go 8 here. Okay, x can't be simplified, so we'll just go x, y squared times y to the first. Okay, 2 and 1 is 3, so this is y to the third. Okay, so now I handled my multiplication. Okay, now we have some division to work with, okay? So 56 over 8 can be simplified, okay, into just the number 7. X to the 7th divided by x to the first. What's our division rule of exponents? Hopefully you're thinking to yourself that it is indeed subtracting of the exponent. You're going to keep your base and subtract the exponent. So this is x to the 6th. And then y to the 4th divided by y to the 3rd. This is just y or y to the 1st. None of these can be combined further, so this is just my final answer. Okay. All right. Why don't you all move on to C, pause the video, give it a try. Okay. I'm assuming you've already paused the video, and then now you are ready for me to do C so you can check your work. Okay, let's go 6 times 9. X squared times x to the 5th, y times y to the 2nd, 3 times 2, just x, and y cubed times y. 6 times 9 is 54. X to the 2nd times x to the 5th is x to the 7th. This is y to the 3rd. This is 6. This is just x. And this is y to the 4th. Okay, so 54 divided by 6 is 9. X to the 7th divided by x is x to the 6th. Y to the 3rd divided by y to the 4th is y to the negative 1st. Hopefully you remember from last chapter that you cannot have negative exponents in your answer and it be considered simplified. Okay, so then what we do is we create an upstairs and a downstairs, And anything with a negative exponent goes down or moves, while anything with a positive exponent stays. 9, stay or go, is going to stay. X to the 6th, stay or go, it's going to stay. Y to the negative first is going to go. It's got a negative exponent, so it needs to move downstairs. So my final answer is 9x to the 6th over y. Okay. All right, so now as we move forward, it's important to note that if I have something like, if I'm multiplying fractions and I have something like 3/6 times 4/9, okay, we can do a little bit of cross simplification here. For example, if I look at the 9 and the 3, both have factors of 3, so I can divide a factor of 3 out to get a 1 and a 3. 3 divided by 3 is 1. 9 divided by 3 is 3. Here I have factors of 2 that I can take out. So 4 divided by 2 is 2. 6 divided by 2 is 3. Okay, and so then I can multiply straight across. 1 times 2 is 2. 3 times 3 is 9. Okay, so when you are multiplying fractions, you have the option of canceling vertically or canceling diagonally. Okay, not straight across, but diagonally. Okay, so you can cancel diagonally or vertically only. Okay, and that will come in handy when we're doing work here today. All right, let's take a look at each of these. Okay, so I have 3x minus 3x squared. All right, and we want to factor that. So there's 2 terms. Neither's a square, but I can factor out. I have a greatest common factor, right? A 3x can divide out of each of these. And when I divide a 3x out of 3x, I get 1. And when I divide 3x out of negative 3x squared, I get negative x. Let's factor the bottom. X squared plus 4x minus 5. It's a 3-term trinomial with an a value of 1. Okay, that means we have to multiply to c and add to b. So I'm again referring to our pink flow chart here. I'll do that once again. Okay, 3-term trinomial. A value does equal 1. We multiply to the c value added to the b value in order to factor. Okay, so I'm looking for numbers that multiply to negative 5 and add to 4. Okay, that's going to be a positive 5 and a negative 1. All right. Here I have a 3-term trinomial with an a value of 1. So 3-term trinomial. A value is 1, so I'm looking to multiply to negative 20 and add to 1. So numbers that multiply to negative 20 and add to positive 1, let you think about that. Okay, that strikes me as that's going to be a positive 5 and a negative 4. And then this is just a 3x here. Okay, so great time to find our excluded values because you're just looking in the denominators here. Okay, x can't be negative 5, x can't be 1, x also can't be 0 because 3 times 0 would result in 0. Okay, so then let's go ahead and do some canceling. So I have a factor of 3x each, and those are going to cancel. These look like they're the same, right? They awfully look very close, right? 1 minus x and x minus 1. Well, are those the same? Because that's the only way that you can cancel is if they're literally the same. Okay, and hopefully you're kind of saying to yourself they're similar, but they're not the same. So these actually don't cancel here. Okay, x plus 5, we can cancel diagonally, so let's go ahead and do that. Okay, and so then what I'm left with here is 1 minus x and x minus 4 all over x minus 1. Okay, so if you can get to this point here, that is fantastic. That's absolutely good work. Let's actually take it to the next level here because I'm looking at 1 minus x and x minus 1. And they're so similar, but yet they're just subtly different, okay? And they're so similar because these are actually opposites. So hopefully we know that opposites are like 4 and -4, 8 and -8. Okay, it's just literally opposite signs. So positive, negative, negative, positive. Well, if we look here, this one is positive, this one is negative. This x is negative, this x is positive. So that means that these are actually opposite factors. So what I can actually do is pull out a -1 out of that top factor. So if I take 1 and I divide it by -1, I get -1. Negative x and I divide it by -1 and I get positive x. Okay. Okay, let's reorganize this so it looks a little nicer for us. So when I take that -1 out, because -1 plus x is the same as x minus 1, they actually turn into the same factor. Okay, so we can now cancel those out because now they are literally the same. Oop. They are literally the same here. Okay, because when I divide out a -1 out of each of these, this is what I get when I reorganize it. And so now you're left with two possible answers that I would take. I would take -1 times x minus 4. Or if you distributed that -1, this would be a situation where that would seem pretty acceptable. Okay, so anytime you're identifying a term like this where they are very similar, but they're just opposites, this is how you can divide a -1 out as a factor. Okay, why don't we take a moment, pause the video, and try letter D on your own, okay? And then check it with my work. Okay, I have now gone under the assumption that you all have tried letter D on your own, okay, and now it's time to check your work. Okay, we're looking at 5x minus 5x squared. We have a greatest common factor in 5x, and you get 1 minus x. Okay, and then I'm looking at x squared minus 4x plus 3. Three-term trinomial and three-term trinomial, and the a value is 1, so I'm looking for numbers that multiply to 3 and add to -4. So those numbers are -3 and -1. -3 times -1 is +3. -3 plus -1 is -4. All right, so then our top here, x squared minus 5x plus 6, three-term trinomial. A value is 1, so I'm looking for numbers that multiply to 6 and add to -5. So that's going to be x minus 6 times x plus 1. X minus 6. No, this actually does not work, right? Because -6 and 1 multiply to -6. Okay, so I'm looking at this again. Let's cross these out. Okay, and I believe that this needs to be an x minus 3, and then this needs to be an x minus 2. Okay, let's double check. -3 times -2 is +6. -3 times, or plus -2 is -5, so that actually works out better. Actually, the other one didn't work at all, so this one is the correct one. Okay, let's find the excluded values quick, just for practice. X cannot equal 0 because 5 times 0 would give me 0. X can't equal 1 because 1 minus 1 is 0. And then x can't be 3 because 3 minus 3 would be 0 also. Okay, let's do some canceling. I have a factor of x minus 3 and x minus 3 and 5x and 5x. Hopefully you've identified the similarities between 4 and letter D. Okay, and that these strike me as opposites, so let's factor out a -1. And then reorganize. So now I do have my common factor. It looks like it is x minus 1. Okay, and so then we're left with two answers. The first being negative 1 times x minus 2. Or if you felt like you wanted to distribute, these are the same. And either would be accepted. We would take either of those since they're equivalent. And both simplified. Okay. So, again, the simplification part comes in that first part of this lesson. So if you're struggling with like how I'm canceling things, you need to go back through the first two examples and go ahead and check those. Otherwise, seek one of us out for help because we are about to move on to some more multiplication. I thought we were moving on to division there for a moment. Okay, so let's think about like if I'm trying to multiply a fraction, like 2/3 times 2. Okay, so if I have 2/3 and I'm multiplying it by 2, I'm doubling 2/3. Hopefully we all know that this is 4/3. Okay, but how can I get to 4/3? Well, I know that 2 is the same as 2 over 1. So whenever I have a whole number, I can just put it over 1 and boom, I have a fraction. Straight across, 2 times 2 is 4. 3 times 1 is 3, and there we are. That's how we got there. Let's see how these problems are very similar to that. Okay, well, I'm looking at x plus 2. Okay, and I'm multiplying it by x cubed minus 27. That might be able to be factored, but I know that x squared plus 3x plus 9 can be put over 1. Okay, so let's go ahead and try to factor x cubed minus 27, because it might be able to be factored. So how many terms do I have? 2, so I got to look for special patterns. Difference of squares, difference of cubes, sum of cubes. So I got to ask myself, I do have an x cubed, so I know this could be a difference of cubes. X cubed, that is a perfect cube. We got to check whether 27 is a perfect cube or not. Okay, so, ooh, it is a perfect cube. So this is definitely a difference of cubes. So let's go ahead and pull up the difference of cubes formula right here. Okay, so we just got to find the root of the first part. So what's the root? What is the root of x cubed? This is like my a value. What's the root of x cubed? Well, that's x. And what's the root of 27? Okay, so if I have my cube of 27, what's its root? It's 3. So then what I can do now is I can go ahead and anywhere I see an A, I can put x. And anywhere I see a B, I can put 3. Okay, and where did I get x and 3? I found that from the root of x cubed and the root of 27. Okay, so the first part is going to be x plus x minus 3, because a minus b. A is x, b is 3, so this is going to be x minus 3. Okay, so then the next one, x squared plus ab, so a times b, so x times 3 is 3x. And then plus b squared, which is 3 squared, which is 9. Okay, remember, we did difference of cubes and sum of cubes in Chapter 5. If you need some more assistance on how to factor this, you'll also see me do it in E as well. Okay, now, if you did this right, this is unfactorable. Let's see why, because it ends up being the same here, as most of you can see already. 1, 2, 3. We have a 3-term trinomial. A value is 1, so we would be looking for numbers that multiply to 9 and add to 3. Well, there is no combination of numbers that multiply to 9 and add to 3. So this is prime, meaning it can't be factored. And we can go ahead and cancel these out. Okay, and so now we're just left with, this cancels out to 1, so I get just x plus 2 over x minus 3. Okay, pause the video and see if this is a problem that you can do, and then check your work when you're done. Okay, so I'm assuming that you've all already done this. Okay, so I have x plus 5 here. And then I'm going to need to factor x cubed minus 1. So let's see how we factor that. How many terms are there? There's 2, so I got to look for special patterns. I see x cubed, so I want to check and see if it's a difference of cubes, because difference means subtraction. And I want to see if these are both perfect cubes. So we already know x cubed is a perfect cube. We just got to check whether 1 is a perfect cube or not. So I go over here, go to my list of cubes. 1 is a perfect cube and its root is 1. Okay, so now we have kind of a value is equal to x and b value is equal to 1. So let's pull that difference of cubes formula up. Okay, so anywhere I see a I'm going to put x, and anywhere I see a 1, I'm going to put, or anywhere I see a b, I'm going to put 1. So we're going to start with a minus b, which would be 1 minus x, or x minus 1. Okay, then x squared plus a times b, so x times 1, which is just x. And then b squared, so 1 squared, which is 1. And then this other part, since it's written as a whole number, we can put it over 1. And then do some canceling out. All right, next. Is we multiply straight across. X plus 5 times 1 is x plus 5. X minus 1 times 1 times 1 is x minus 1. Okay, so the hardest part for these problems is definitely going to be whether you can factor those parts out or not. Okay, we are getting down there to the end of this. All right, let's recall division of rational expressions. So let's first relate this back to just some general rules that we use with fractions. Okay, if I have a half and I'm trying to divide it by and I'm trying to divide it into fourths. So how many fourths are going to fit into a half is this question. Okay, if you remember, the trick is you're going to keep your first fraction. You're going to keep flip change. Okay, so we're going to turn our division into multiplication, and then we're going to flip the fraction here. Okay, so division of a fraction is the same as the multiplication of its reciprocal, and this needs to be a 1. Okay, is the same as, okay, so you're going to keep your same one. Division turns into multiplication, and then you're going to flip this fraction here. Okay, so 1 times 4 is 4. 2 times 1 is 2. This is just equal to 2. And that makes sense that a fourth fits into a half exactly 2 times. Okay, these problems can be done the exact same way, just with a little bit of factoring in how we cancel. Okay, so we look at this first one, and we have a 7x, and we're dividing it by 2x minus 10. That can be factored by taking a 2 out and getting x minus 5. Okay, we know that we're going to change our division to multiplication, and then we can flip this fraction right now. We'll factor next step. Okay, so I kept the first one. I did factor here, and then I division to multiplication, and then I flip this around. Okay, so this part's already simplified, so let's just simplify the next part. Okay, so x squared minus 11x plus 30, 1, 2, 3 terms. A value is 1, so I'm looking for numbers that multiply to 30 and add to negative 11. So go ahead and think about what combination of numbers that is. Okay, and hopefully you've identified that this is going to be x minus 5 and that this is going to be x minus 6. Negative 5 times negative 6 is positive 30. Negative 5 plus negative 6 is negative 11. Okay, and then here, x squared minus 6x. We're looking for common factors here. We only have 2 terms, and it's not a difference of squares. Even though this is a perfect square, 6x is not a perfect square. Okay, so we're just looking for greatest common factor, which we can pull an x out, and then be left with x minus 6. Okay, so now we're looking for common factors vertically and diagonally. Okay, so first factor of 7 cannot be canceled with this 2. Factor of x. There's a factor of x here. There's a factor of x here. That can be canceled. Okay, then I have factor of x minus 5, and then that factor of x minus 5 here. Those can be canceled. X minus 6 factor here, x minus 6 factor here can be canceled. So what am I left with? I'm just left with the 7 times 1 times 1 times 1, which is just 7, and then 2 times 1 times 1 times 1, which is 2. So this particular problem simplifies down into just a nice, neat fraction of 7/2. This problem is the same as multiplication. There's just like one extra thing that you need to do, right? What's that one extra thing? Hopefully you're all saying to yourself, it's just you need to change your multiplication, your division to multiplication, and flip your fraction, okay? So again, this is just, this is multiplying by the reciprocal. Division of a fraction or a irrational expression is the exact same as multiplication of the reciprocal. Okay, as always, pause the video, check out letter F, okay? Try that one as far as you can do on your own, and then check it with me here in a moment. Okay, so hopefully we're identifying that we can turn this into a multiplication problem. Okay, so I just wrote everything back down, but then I said, hey, this division is multiplication. I'm going to flip this. Okay, let's factor. 11x cannot be factored. 3x minus 9 can be factored, right? Common factor of 3 in each of them. So we're going to take a greatest common factor and say this is x minus 3 then. 3x minus 9 is the same as 3 groups of x minus 3. X squared minus 8x plus 15 is a trinomial, 3 terms, 1, 2, 3. And I'm looking for numbers that multiply to 15 and add to negative 8. Think about those numbers on your own. Okay, hopefully you've come to the conclusion that that's negative 3 and negative 5. Okay, bottom part, not a difference of squares because 5x is not a perfect square. So we just take the greatest common factor of x out to get x times x minus 5. Okay, let's start canceling. Factor of x here, factor of x here. Factor of x minus 3 here, factor of x minus 3 here. Factor of x minus 5 here, factor of x minus 5 here. So let's think what's left over. 11 times 1 times 1 times 1. 3 times 1 times 1 times 1. So this one simplified just into 11/3. Okay. One more page, folks, and then we are done with this section, and you can move on to the homework. Okay, so now what we have is a division of a like a whole number, right? So let's say I'm taking 2/3 and I'm dividing it by 2. Okay, so hopefully we know if we're dividing 2/3 and we're cutting 2/3 into half because we're dividing it by 2, this is going to end up being 1/3. Because half of 2/3 is 1/3. And where halving is the same as dividing by 2. Okay, but let's go through the process of how we could get to that answer. Right? I would say, well, 2 needs to be written as a fraction for me. So I'm going to write as 2/1. And then what was the rule that we just worked on? Right? When I'm dividing a fraction, you're just going to change division to multiplication, and then the reciprocal of this fraction, 1/2. Okay, and then we can actually cross cancel, right? These cancel out to 1s. Then I get 1 times 1 is 1. 3 times 1 is 3. Okay, so we got there no matter how we did it. Okay, same thing is going to be true for this. Hopefully you see the similarities. Okay, I have 6x squared plus x minus 15. Okay, so 6x squared plus x minus 15 over 4x squared. And then I'm going to turn this into division of 3x squared plus 5x over 1. Okay, and then I got to turn this into a multiplication problem. By multiplying by the reciprocal. Okay, so now I'm really glad that we had this problem because here's our first example of this chapter, even though we've gone over it pretty extensively, of a different method of factoring. Okay, so let's go ahead and factor 6x squared plus x minus 15. Let's go through our flow chart. Okay, so as I'm looking through this, how many terms are there? There's 3. Does my a value equal 1? No. Ax squared, my a value is 6, so my answer to that is no. What do I have to do? The Xbox method. Okay, Xbox method here is diagrammed below about how we can factor that. Okay, so the Xbox method, I'm going to do this way below here. Okay, you're going to put your b term here. What's my b term? A, B, C, so b term is 1. Okay, and then bottom is going to be a times c, which is 6 times negative 15. Okay, which is negative 90. Okay, so now how do I find these sides? Because that's important. I need to find the sides to be able to figure out what multiplies, because that's what I'm trying to do, is I'm trying to figure out what's going to multiply here and add here. Okay, so I'm going to walk you through what you can do if you have literally no idea, because sometimes the numbers will pop in your head right away and other times they will not. What you need to do is you just need to start listing combinations. Is 1 and 90 ever going to get me to adding to 1? No. So then I can go to 2 and 45. Is that going to get me there? No. 3 and 30. Is that going to get me there? What about 90 and 4? Does 90 divide by 4? Not evenly. Okay, so then we can do 5. Okay, and that is 18. So 5 and 18. We're getting closer, but that's not the combination. So we're going to divide it by 6. And we are going to get 6 and 15. That's not the combination. So we're going to go 90 divided by 7. No, 90 divided by 8. No, 90 divided by 9. And there it is, 9 and 10. There is some combination that will get me to 1. Okay, so now I have to think what combination of the positive and negative 9 and 10 are going to get me to negative 90, but also add me to positive 1. Hopefully you're saying that, yes, this needs to be negative. Okay, so then we could set up our box and actually factor. So here goes your ax squared term, which is 6x squared. Here goes your c term, which is negative 15. And then what you do is you put these numbers here on the sides with an x. Really all you're doing is you're decomposing 1x into negative 9x and positive 10x. And then you can start taking negatives out. You take negatives out where you see 2 in a row. So I'm going to have I'm going to have a negative here. Not there, not there, not there, not, okay, right here. Then you just ask, what's the greatest common factor? What's the greatest common factor between negative 9x and 15? What's the largest value that divides out evenly out of each of these? So 9 and 15, what's the largest number that divides evenly out of both? That is 3. Okay, you can do the same here. What's the largest value that divides evenly out of both of these? 6 and 10, largest number is 2. X squared and x, largest value is 2, or x. 6x cubed or squared and negative 9x. Largest number that divides out of 6 and 9 is 3. Largest number that divides out of x squared and x is x. And then here, 10x and negative 15. What's the largest number that divides out of 10 and 15? That's just 5. Okay, so there's my two factors. Okay, and then now I just have to factor here. Here I have two terms, but 3x squared is not a perfect square or a perfect cube, so I just need to see what's the largest value that divides out evenly out of this. That's just an x. 3x squared divided by x is 3x. 5x divided by x is just 5. Okay, so now I can start finding parts that cancel here and here. And then you got to ask yourself, does x and x squared have a part that cancels? In this situation, no, because you only can cancel vertically and diagonally here, and this is a horizontal move. Okay, so our final answer is 2x minus 3 over 4x. Well, x squared times x is x cubed. So this here is my final answer. So these problems require a little bit more work just because the factoring method is one that's a little more extensive, but something that we've done a lot of work with. Okay, pause the video, move on to letter G and try that one on your own. Check your work with me when you are done. Okay, so I'm assuming that you've already done this work. So we know that this is going to be, well, this has a greatest common factor. Let's actually do that right now, right? 6, 4, and 2 all have a greatest common factor. So we're going to take a 2 out and get 3x squared plus 2x minus 1 over 5x squared. And then I'm just going to turn this into multiplying by the reciprocal right now. Change division to multiplication and flip this around. Okay, now I need to factor this, which is going to be 3 terms. A value, not 1. We have to use Xbox method. A times C goes down here, so this is negative 3. B value goes here, so this is 2. So I'm looking for numbers that multiply to negative 3 and add to 2. And that is going to be 3 and negative 1. Okay, so then we can use the box to actually get the factors. Okay, so 3x squared goes here, negative 1 goes here, and then I'm going to go 3x here, and negative 1x here. I'm going to take negatives out where I see 2 negatives in a row or diagonal x's, and I have 2 negatives in a row, so I'm going to take a negative out here. And let's just start taking greatest common factors out. What's the largest value that divides out a 1 and 1? Which is just 1. What about 3x and 3x squared? So 3 and 3, largest number that divides out of that is 3. X squared and x, the largest value that divides out of that is x. Largest value that divides out of 3 and 1 is just 1. Largest value that divides out of x and x squared is x. Largest value that divides out of 3x and negative 1 is 3 and 1. What goes into that? That's just 1. Okay, so this is going to factor into 2 times x plus 1 times 3x minus 1. Then we need a factor here. 2 factors out. X also factors out. So 2x times 2x divided by 2x squared. 2x squared divided by 2x. So 2 divided by 2 is 1. X squared divided by x is x. 2x divided by 2x is 1. So let's cancel where we can. So it looks like x plus 1 is going to cancel here. That's about it. So here I'm going to have 2 times 3x minus 1. And then on the bottom, I'm going to have 5 times 2 is 10. X squared times x is x cubed. Okay, and actually I do have an additional factor here because 2 and 10 each divide by 2. So this is 1. This is 5. To get 3x minus 1 over 5x cubed. Okay, and this needed to be x cubed because x times x squared is x cubed. Okay. So as you can see, these problems do get a little bit more complicated, but really, folks, as we're doing these problems, there is nothing new about these problems. It's just an elaboration upon information we already knew. For example, in theory, we already knew how to divide involving fractions. Multiply by the reciprocal. We've already taught an extensive amount of lessons on how to factor. And then really the only added part is just knowing when things cancel. Okay, so I understand that the piecing together of all of this can be complicated, but just try to break it into little chunks that you know how to do. You know how to divide rational expressions because you know it's just multiply by the reciprocal. You know how to factor, just factor individual parts like you have done in the past. And then you know how to cancel, hopefully, by now because you're just looking for the same part and then cancel when those arise. Okay, last problem. Okay, so we know that the total annual income I in millions of a personal income earned in Alabama and its annual population P in millions can be modeled by. So here is your annual amount, okay, and this is the expression that represents it, and here is P, the population, okay. So we're trying to, when this represents the income they have and this is the population, so what would we do if we're trying to, we know T represents the year with T equal to 1 represents 2001. Find a model M for the annual per capita income and then estimate in 2010. Per capita income means how much income per person. So we got to take the income and divide it by the principal. So we know that the model M is going to be equal to, if I take my income and divide it by my population. Well, we have representations for income and population. So let's go ahead and do that. So we're going to 6922T plus 106,947 all over 0.0063T plus 1. We're going to divide it by 0.0343T plus 4.432. We're dividing by this entire thing. Okay. So let's just simplify this model, okay, and change this to multiply by the reciprocal of that. So we're going to write the same thing down on the left. Okay, so here's the same, and we're just going to turn this into multiplication of the reciprocal of this. So remember that when it's like written as a whole number, it's over 1. So now it's 1 over 0.343T plus 4.432. Okay. So here's our model, and we want to know when T is equal to 10, because if T equals 1 is 2001, T equals 10 is going to be 2010. So our model is going to be 6922 times 10 plus 106,947 all over 0.0063 times 10 plus 1, and we're multiplying it by 1 over 0.0343 times 10 plus 4.432, and this is going to be, needs to be in black. Okay, so let's just figure out what this number is here. Okay, so I can just go ahead here and go 6922 times 10 plus 106,947. Okay, and that's the top left number, 176,167. Okay, let's figure out what this number is here. Okay, so this is going to be 0.0063 times 10 plus 1 is 1.063. Okay. Now we just identified what this number is here. Let's identify this number here because that's going to be 1. So 0.0343 times 10 plus 4.3432. Okay, and that is 4.775. Okay, so hopefully what you noticed here is since these numbers are going to be very messy numbers and numbers that don't, or like expressions that don't factor, we're just going to get it in a form that it's just multiplication, and then we can just evaluate each individual part. Because now we can just multiply straight across here, right? Okay, 176,167 times 1 is just that same number. Okay, and then 1.063 times 4.775. 1.063 times 4.775. Okay, I'm going to write that whole number out so I don't double round. You don't want to round more than one time in a problem, so you don't ever do that in the middle of a problem. Okay, and so then now all I have to do is this top number divided by this bottom number. $5.075825. And I'm going to round to the nearest tenth because we're talking about dollars and cents. Okay, so what does this mean when it's all said and done? All right, this is the average per capita, estimated per capita income in Alabama. So the average person in Alabama is making about $34,707.07. Okay, so this is kind of the answer to the estimate per capita income, and the model M is going to be this line right here, the one that sets our division into a multiplication of just expressions that we can evaluate individually. Anyway, folks, now is a fantastic time to go ahead and just try some problems on your own. Okay, so go ahead and get the 7-3 worksheet out and give it your best shot. Reach out to one of us if you have any questions. Otherwise, I will see you all next time.